In this video, we're going to solve the exercise from the previous section. We have give the proof by contradiction of the theorem if 3n plus 2 is odd, then n is also an odd number. So you'd consider this one as our P and this one as our Q. So the whole statement is basically an implication, and if we're going to express this logically, this is P implying Q, and let this be basically the whole premise. Say, let's make it the whole premise R, for example. So, giving a proof by contradiction, firstly, we're going to negate the whole statement. So, if you negate the whole statement, and assume this to be true. So what is the negation of the whole statement? So if this is P implying Q, if you negate this, you will end up with, using implication equivalence, you have P or not of P or Q by implication equivalence. And if you use De Morgan's, this will be not of not P and Q, or not of Q. If you're using double negation now, the whole thing is P and not of Q. So therefore, the negation of your implication is equals to P and not Q. So that means if 3n plus 2 is odd, then n is odd. The assumption here will be P and not of Q. So that means the assumption is 3n plus 2 is odd, so this statement, and I have n is odd. Or in this case, not of Q, so n is even. Again, we're simply just following the negation of the statement, which is P and not Q. So if we proceed now with the solution to this, okay, we will have, so let's proceed. So we're going to assume that this will be true. So again, the verb here is assume. Now, if we assume that this is true, this is conjunction, so the first statement should be true and the second statement should be true for the whole statement to be true. Therefore, by assumption, we have 3n plus 2 as odd and n as even. by assumption using proof by contradiction. Now, the second step will be to somewhat show any contradiction. Okay? Show a contradiction so that we will be able to prove the original statement. Because if the negation of the statement ended up with a contradiction, then the original statement is true or is proven to be valid. So we are going to use n as even which can be any number. N equals twice of k. So where k will be any integer. So we could now assume, or we could now show this 3n plus 2 is equals to an odd number. So using algebra now, we could substitute the other assumption, so to the first. So 3 times twice of k plus 2. So if we factor out 2, factoring out 2, you get 3k plus 1. And if you let say any number m, for example, is equals to 3k plus 1, then we could end up with a number which is twice of m, which is a number that is even. Now, this finding or this result is a contradiction to the original one, or the assumed truth, which is 3n plus 2 is an odd number. So we have showed, based on algebraic manipulation, that 3n plus 2 is even, and even contradicts the initial assumption that this number is odd. Therefore, by contradiction, the original statement, which is 3n plus 2 is odd, then n is odd, the original statement is proven to be valid. And again, that is by contradiction, showing a contradiction. So that's it.